Okay. Sorry about that. I'm going back to my full webcam. Okay, so I'm going to talk about Lab 2. And Lab 2, we would have done it in class. We wouldn't have used a true spring scale. We would have used a force sensor, sorry, which I thought I had laying around. But this lab was designed to help you understand the difference between weight and mass. So this is a spring scale, and a scale measures a force. This is a balance, and a balance measures mass. And what the big difference is gravity. So if we take a look at this, this is a teeter-totter, this is the fulcrum, this is what it teeter-totters across. We have gravity on this side and we have gravity on this side. So if you were on a teeter-totter and you had a 5-pound plate on each side, it would equal out. Here we have gravity on each side and it equals out. So this is a balance and it takes gravity out of the picture, so this is mass. This is a spring scale and it has gravity in it, so this is weight and it will be in newtons. Now, just like the picture in the reading, it has, and you're probably not going to be able to see it, it has grams on one side and newtons on the other. So that idea that there's a difference between weight and mass, it's true. There is. For the majority of the people, it's not a big deal. Don't tell anyone I said that. So when we have weight and mass using a spring scale, it just has divided it out for you. Okay. I'm going to switch over to the worksheet. And as we take a look at the worksheet, there was our force sensor or spring scale. And when you went through and did the graph, it should have been 0 and 4 point something, 1 and 9.8. And as you went, the slope should have been 9.8 or something about that, around there. And I'm okay with you using 10. So the slope should be about 10. And what that tells us is if we take the mass in kilograms, and it's got to be in kilograms, my spring scale is in grams, times 10, we should get our force in newtons. So kilograms is the standard. So this lab was designed to help you understand the difference between mass and weight. Mass in kilograms, weight in newtons. So explain what would happen if, to your data, if you were to take the equipment to the moon and perform explain what would happen to your data if you were to take the same equipment to the moon and perform the experiment. Your slope would be different. It would still be a straight line, but seeing the gravity is different, the weight is different. And as we go, we're going to find out that instead of about 10, it's about 1.6, if I remember right off the top of my head. Okay. So many unit conversion tables contain the following. 1 kilogram is equal to 2.2 pounds. Explain what is wrong with that equation. So a kilogram is a measurement of mass and a pound is a measurement of weight. At sea level, 1 kilogram is equal to 2.2 pounds. But the farther you get away from the Earth, the less that difference is going to be on the Earth. So as you go farther and farther and farther away from the Earth, your mass is going to stay the same, but your weight will go down. Now, is it a big difference? No, it's not. Just about anywhere you are standing on the Earth, you are still going to have pretty close to the same weight. Probably within a pound. And I think it might actually be less than a pound if you were the difference between being on the Earth and Mount Everest. Okay, so there are a lot of times that use that conversion. Number 4, it is commonplace to find statements on food cans such as net weight 16 ounces or 454 grams. Why do most people find this acceptable? Why do physics types object to it? When you buy a can of beans for your chili, you don't care that if it's in ounces or grams. 16 ounces is a weight, 454 grams is a mass. The majority of the population don't care. Physics types, on the other hand, say this is weight, this is mass. You cannot make that conversion because if you were to take that to the moon, its weight would not be 16 ounces. It would be something less than that. Its mass in grams would be the same. And then number 5, that came from your reading. And the question is, carefully examine each scale in the scale reading. Are the readings correct for the representative scales? What would each scale read if we were to put the same 500-gram object on the moons? As well as you can read. They are correct. It's not the best picture. In theory, the scale measures grams, and it would be the same, but it wouldn't because it's a scale. This is a spring scale. If you took this to the moon, it would read weight, not mass. Even though it's labeled in grams, it would not read correctly because it is a scale. Number 6, when you go to the doctor's office and you step on a balance, which in the US is typically calibrated in pounds. So if you go to the clinic over here and it's been a while, you step on it and they tell you your weight in kilograms. You don't tell weight in kilograms, you tell mass in kilograms, you tell weight in newtons. So what this question is trying to get at is what you are reading or what they are reading to you is your weight, and it is your weight then converted into kilograms. They don't actually have a balance, they have a scale that converts it. So I hope that helps a little bit. I'm sorry if I went too fast. Just trying to keep these videos as short, sweet, and concise as possible. Any constructive criticism, whether it's good, bad, or indifferent, I would love to have. Have a great day. Thanks.